Nearly 16 billion miles from Earth, farther than any human creation has ever gone. Voyager 1 continues its quiet journey through interstellar space. It was never built for this kind of lifespan. Designed in another era, with expectations measured in years, not decades, it has endured far beyond its original purpose. And still, it moves, around 38,000 miles per hour, sending back a signal so faint it almost feels impossible that it reaches us at all. Out there, the sun no longer dominates the sky. It has shrunk into just another distant star, barely distinguishable among countless others. Light is weak, warmth is gone, and the environment is not the dramatic emptiness we often imagine, but something deeper, in endless, motionless stillness. No wind, no sound, no movement. Just a vast, uninterrupted silence. Yet Voyager is not completely silent. Each day, it sends a signal toward Earth. That transmission travels at the speed of light for nearly 24 hours before arriving. By then, it is unimaginably weak, carrying less energy than the smallest everyday electrical devices spread across an immense distance. And still, it arrives. A fragile connection between humanity and the most distant object it has ever created. But that signal is always delayed. What we hear is not the present, it is the past. When the data reaches us, it tells the story of a spacecraft as it was almost a day earlier. A mechanical heartbeat echoing across space. Inside that signal are temperature readings, particle measurements, magnetic field data, and system updates. Each piece confirms that something built decades ago is still functioning, still existing far beyond the solar system. Its survival, however, is becoming increasingly uncertain. Voyager 1 runs on radioisotope power, heat generated from slowly decaying material, converted into electricity. At launch, it had enough energy to operate all systems. Now, nearly 50 years later, that energy has diminished significantly and continues to decline. To extend the mission, engineers have been turning off instruments one by one, not because they are broken, but because there is no longer enough power to sustain them all. It is a gradual shutdown, carefully managed, as the spacecraft slowly loses its ability to function. When Voyager began its journey in 1977, expectations were modest. A few years of operation, perhaps a decade at most. Its mission was to explore the outer planets, Jupiter and Saturn, and then fall silent. Instead, it changed everything. At Jupiter, it revealed active volcanoes on Io, massive storms, and complex atmospheric phenomena. At Saturn, it uncovered intricate ring structures and unexpected details about its moons. These discoveries reshaped scientific understanding in ways no one had predicted. After completing its primary mission, Voyager did not stop. It continued outward, leaving the planetary region behind. In 1990, it turned back one final time and captured an image of Earth from billions of miles away, a tiny, pale point of light suspended in space. After that, its cameras were turned off forever. There was nothing left to photograph ahead. Time passed. Years turned into decades. In 2012, Voyager crossed the boundary of the heliosphere, the region dominated by the Sun, and entered interstellar space. It became the first human-made object to reach that distant realm. Beyond that boundary lies a different environment, shaped not by our star, but by the combined influence of many others. And then, something unexpected began to appear. Over time, small irregularities showed up in the data Voyager sent back. At first, they seemed minor, slight distortions, mismatched telemetry, signals that didn't behave exactly as expected. These were easy to explain: aging hardware, interference from cosmic radiation, or simple noise. But the anomalies didn't disappear. When researchers re-examined the data using more advanced computational methods, patterns started to emerge. Not random noise, but subtle structure, repeating intervals, faint symmetry, hints of organization. Initially, this was dismissed as human tendency to find meaning in randomness, all pointing to similar results. Even more intriguing, some of these patterns appeared to correlate with the spacecraft's own behavior, its orientation, antenna adjustments, and unexplained fluctuations in its systems. This raised an uncomfortable possibility. Voyager is not designed to interact with anything. It drifts passively through space. But the data suggested something else, a connection between external influences and internal responses. The anomaly appeared repeatedly, across different timeframes and datasets. It behaved less like an isolated error and more like a persistent feature of the environment. That leads to a difficult question. Is Voyager simply passing through something unusual? Or is there something moving with it? At the same time, its signal began to show more structured distortions. Not random degradation, but something almost rhythmic. Engineers describe these effects cautiously, using careful technical language. But the behavior doesn't always match what would be expected from a failing system. At times, it seems almost as if the signal is being shaped. Voyager's location makes this even more intriguing. It is far beyond the protective influence of the Sun, in a region once assumed to be uniform and uneventful. But that assumption may not fully capture reality. Because Voyager is still transmitting. Still reacting. Still sending back information from a place we barely understand. And every time that faint signal arrives, it carries more than just data. It carries uncertainty. One day, the signal will stop. Not with a dramatic ending, but with silence. Power will drop below the level needed to communicate, and the connection will simply fade away. Voyager will continue its journey regardless, silent, dark, and drifting through the galaxy. Inside it, the golden record will remain, carrying traces of humanity long after the spacecraft itself can no longer speak. And even after the signal is gone, one question will remain. What, if anything, was out there with it? The silence, when it finally comes, will not answer anything. It will only deepen the mystery. Because by the time Voyager 1 goes quiet, it will have already crossed a region we still barely understand. Every bit of data it sends now is not just information. It is the last glimpse into a place no other instrument has reached. And what it has hinted at so far does not fit comfortably within expectations. The patterns in its transmissions have not announced themselves clearly. They are subtle, almost reluctant to be noticed. Buried within noise, hidden behind the limitations of distance and aging hardware. But their persistence is what makes them difficult to dismiss. Random errors tend to scatter. These do not. They repeat. They evolve. They appear tied, in some unclear way, to Voyager's own state. That alone would be enough to raise questions. But there is something more unsettling beneath it. Voyager was built to measure, to observe particles, fields, radiation. It was not designed to interpret, react, or adapt in any meaningful sense. And yet, some of the irregularities suggest responses that feel timed. Not intentional, not conscious, but also not entirely passive. There are moments where shifts in the signal coincide too closely with environmental readings to be easily explained as coincidence. Slight adjustments in orientation followed by changes in interference patterns. Variations in data flow that mirror external fluctuations. Individually, each could be dismissed. Together, they begin to form something harder to ignore. Still, caution matters here. Interstellar space is not truly empty. It contains charged particles, magnetic turbulence, and regions of varying density shaped by forces we are only beginning to understand. It is entirely possible, likely, even, that Voyager is encountering structures within this medium that behave in ways we have not yet modeled correctly. Complex interactions can produce patterns that look meaningful without being guided by anything intentional.